Okay, we want to talk a little bit about what the graph of how to use the graph of a function. So we have here a graph of a function. We're familiar with graphs. This isn't one of our basic functions. This might well be a polynomial function of some kind. We'll see what that is later. Excuse me. Okay, and we're going to call this function. We need a way to refer to the function. We're going to call the function f of x, a function of x, meaning that if you give this function x, it'll give you a y value. So if I have a value of x here, I'm going to get a y value that goes with that value of x. We'll see how that works. Now, first thing we want to do is, this is an unscaled graph. We want to scale this graph so that the x values run from -3 to 15. So we're going to put -3 over here, and let's extend the graph a little bit so we actually get to -3. And we're going to scale, well, we continue the scaling by marking where x equals 15. So here's a scale that goes from -3 to 15. And then we're going to get 3, 6. Well, I'm marking those too close, huh? I'd better be a little more careful how I scale this thing. So let me get rid of those marks. Okay, see if we can do that without smudging it too badly. Okay, well there's 15. Halfway between here would be 7.5. That's halfway between, so I think if that's 7.5, it would be reasonable to make this 6. We'll make this 3. That's not much different than what I've already done. And then we'll have 9 here and 12 here. Okay, well, that gap's a little bigger than this one, but we're going to go with it. Okay, I didn't do a very good job of scaling that. Could have done a little better. And I want to scale the y-axis from -10 to 60. So the y-axis goes just down to here. We'll call this -10. Well, actually, I'd better be careful. I've only got this much room up here. So I'm going to call that 60. I'm going to divide this interval in half, approximately. And I'll get 30. And then I'll try to put a couple of marks in here, just give us equal spacings here. So I've got 10 here, 20 here, 30 here, and we'll put 40 here, and 50 here. I don't think I did too badly with that one. That gap looks good. And then -10, we'll put down here. I didn't do a great job with that. You can probably do a better one, but when we're just doing estimates and scaling, anything reasonable is okay. All right. It wouldn't be reasonable to put 3 here, and 6 here, and 9 here, and 12 here. Okay, hopefully that's obvious. Okay, so now we've got the graph scale. Now what we want to do is we want to answer several questions. We want to estimate the value of x when y equals 20. Now, that means, of course, for this function, we want to develop, to estimate the value x takes, the value of x you need in order for the function to give you 20. So, well, y is going to be 20. Well, y equals 20 everywhere along this horizontal line through the y-axis at 20. Now, we don't have to go far before we hit the graph. And once we hit the graph, we can see what value of x goes with this point. And that looks like a little less than 1. Okay, now you might estimate, okay, that's 1. Well, I'd accept that estimate, but I want to be a little better than that. I think it takes 1, 2, 3, almost 4 of these to make 3. 3 divided by 4 would be 0.75. Now, it takes almost 4, not quite 4, so I'm going to estimate that this is 0.8. As I say, if you eyeball it and just say that's 1, that's fine. If you want to be a little more specific about that, it'd be your benefit, but probably wouldn't make any difference in your grading, but you'll learn a little more that way. It's worth a little extra care if you have the time. Okay, so x equals 8. So we can make the statement over here, okay? The point point 8, 20, looks like it's on the graph, so our answer is x equals 0.8. Now, as it turned out, I wish I'd have given myself a little more room. There's a little more that I'd have liked to write there, but we'll go with what I have. So, that's our estimate. The value of x when y equals 20 is 0.8. Okay, let's estimate the value of y when x equals 8. Okay, well, first of all, we want to find x equals 8 here. And we can come up to the graph. We can come over here. And that line kind of declined a little bit, so I'm not going to get a great estimate. Probably 36 or 37. The line kind of decreased a little bit, so I'm going to estimate maybe 37. So my answer is the point 837 looks like it's on the curve. So our estimate is y equals 8. Y equals 37. Now there's something we can say here. We can say that f of 8 equals 37. And up here, we could say that f of 0.8 equals 20. I didn't write that up here, but we could have made that statement. Okay? This means that the function, when x equals 8, gives you 37. And since the function at a point value of x gives you y, that means that f of 8 has to equal whatever the value of y is when x equals 8, and that's 37. Okay? Okay, so there's that picture. Now we have a few other estimates to make here. And I think I'm going to let this video be long enough, and we'll answer these on the next one.